for this computer. Okay. So chapter 6, guys, for MHF, advanced function, and chapter 5 of MCR pertains to trigonometry. This is a new unit. Okay, so what is it about? So I'm gonna very briefly, very quickly review trigs that we know from grade 10, and then we're gonna go over grade 11 and then grade 12 material. Okay, so we said that we have two types of triangles. We have right angle triangle and non-right angle triangles. If a triangle is a right angle, and this is angle theta, in respect to theta, this is the opposite side, this is the adjacent side, and this is hypotenuse. And consequently, we can conclude two theorems here. One is Pythagorean theorem, which says the summation of the squares of the legs of a right angle triangle equals to the hypotenuse square. Number two, we can talk about SOHCAHTOA, sine, cosine, and tangent, which are technically the three trig ratios pertains to a right angle triangle. Sine is going to be opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And also we have secondary trig ratios or rational trig ratios. So we have something called cosecant, which is the reciprocal of sine, so 1 over sine theta. We have secant theta, which is reciprocal of cosine. And we have cotangent theta, which is the reciprocal of tangent. And when we say reciprocal, that means if sine is opposite over hypotenuse, cosecant would be hypotenuse over opposite. Secant would be hypotenuse over adjacent. Cotangent would be adjacent over opposite. Okay, so these are the stuff that we talked about, right angle triangle. Then also we said that if a triangle is not a right angle triangle, in order to solve it, in order to find the unknown variables, let's say if it's a scalene triangle, for example, let's call that this is A, B, C. So this side is A, this is B in front of B, and this is side C. Then we can use two things. Number one was sine law, which states that sine of angle A over associated side A equals to sine of angle B over side B equals to sine of angle C over side C, which is a constant number K. Okay. Of course, you can write it in reciprocal format too, like A over sine A equals to B over sine B equals to C over sine C, which is gonna be another constant. Let's say 1 over K, which is a constant too, right? Let's call that constant M. Number two, the second thing that we learned is that we can use cosine law. So cosine law states that if you know two sides and angle between them, then the third side, side C squared equals to A squared plus B squared minus 2 times A times B multiplied by cosine of angle C, right? And if you isolate for angle C, you can write it this way. You can say cos inverse of side C squared minus side A squared minus side B squared all over negative 2 times A times B. That will give me angle C. So sine law, cosine law, Pythagorean theorem, and trig ratios are the concepts that we learned in grade 10. Okay. In grade 11 in MCR for Justin and Haran, we're going to talk more about the trig identities. We have something called trig identities. So we try to write everything in terms of sine and cosine. So first of all, tangent theta or tangent x can be written as sine theta over cosine theta. As well as cotangent theta can be written as cosine theta over sine theta, because we know that cotangent is cotangent is like the reciprocal of tangent. It is like 1 over tangent. So that would be cos theta over sine theta. Okay. We already knew secant theta is 1 over cosine theta, and cosecant theta, CSC theta, would be 1 over sine theta. So this way we can write everything in terms of sine and cosine, basically. Okay. Also, we have Pythagorean identities that we can use for proof-based problems. Sine squared plus cosine squared equals to 1. 1 plus tan square theta equals to secant square. And 1 plus cotangent square theta equals to cosecant square theta. Okay. So these are the connections, these are the relationship between the trig ratios that we can use all the time. But let's dive into like what is sine, what is cosine, what is tangent. More specifically, we have something called a unit circle to understand it better. A unit circle is a circle with radius of 1, right? That's what's called a unit circle. So if I draw a circle like so, okay? So if it's a unit circle, that means the radius is 1. So here is 1, 1, here's to the left side. So -1, here's going down. So that's -1, right? So if I have an angle theta, all right? If you want to find and the coordinate of this theta here is going to be like x and y, right? So if I want to find x, you go perpendicular to the x-axis. This distance is actually called cosine theta. If you want to find the y coordinate, that would be sine theta. So basically, x is cosine theta, and then y is sine theta. And the rest of trig ratios can be defined by sine and cosine, like we showed, right? Tangent is sine over cosine, cotangent is cosine over sine, secant is 1 over cosine, and cosecant is 1 over sine. Okay, alrighty. And the hypotenuse of this right angle triangle would be 1 because it's a unit circle. That's the radius of the circle, which is 1. And since it's a right angle triangle, you see this side is cosine, this side is sine, so hypotenuse must be 1. So that actually proves the quadratic equation sine squared plus cosine squared equals to 1, right? Okay, so this is the unit circle. Also, more about unit circle, we can divide the unit circle into different quadrants. Quadrant 1 is from 0 to 90 degrees. Quadrant 2 from 90 to 180. Quadrant 3 is 180 to 270. And from 270 to 360, that would be quadrant 4. We have something else called CAST rule, CAST, which means that, or which represents, C stands for cosine, S stands for sine, T stands for tangent, and A stands for all. So that means in quadrant 1, all primary trig ratios are positive. In quadrant 2, sine is positive. In quadrant 3, tan is positive. In quadrant 4, cosine is positive. So these are the 4 quadrants where which indicates which trig ratio is going to be positive. Okay, cool. So nothing new for advanced function students so far. Then we also discussed in grade 11 for Justin and Haron, we discussed about 2 special triangles, which again, for grade 12 students, we're going to use them again. One of them is 30-60 degree triangle, right? If this is 30, that would be 1. In front of 60 would be root 3, and a hypotenuse would be 2. And another triangle, which is 45-45 triangle. So this is, let me draw that again better. So this is 45 degrees, this is 90 degrees, this is 45. So the sides are equal, 1, 1, root 2. Okay, cool. So these are called primary, or sorry, the special triangles that these are the primary angles that we deal with. So the angles that we are dealing with a lot, you're going to see is like 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 180 degrees. Actually, before 180, we have 120. Sorry, with 30, that would be 120, 150, 180. I'm going to write it down here, 210. 230, 200 and yeah, 225, sorry, 240, 270, 300, 330 degrees, and 360 degrees. Now, these are the angles that you're going to see a lot. And if you know sine, cosine, and tangent for these three, for these angles, all these three trig ratios, sine, cosine, and tangent, then it should be good. And using special triangles will help you to do that. Like, for example, if the question tell me to figure out what is sine at, let's say, 300 degrees. Well, first step, I'm going to go to the unit circle. Where is 300 degrees going to be? Well, according to the law, we know that 0 is here, and going counterclockwise would be positive direction, going clockwise would be negative direction. So since it says positive 300 degrees, that means start from 0 all the way to here would be 270. 30 degrees more would land somewhere here. So if I go here, I go perpendicular to the x-axis. Always you go perpendicular to the x-axis. So I make this little triangle here. So if I zoom in to this triangle, this is what I'm going to see. So this is 60 degrees because this is 300. So that is 60 degrees short of 360. So this is 60, 30 triangle. So this is 1. Since it's going to the positive is 1, but the y a component of this triangle would be negative root 3 since it's going down, right? It's to the negative direction of the y-axis, and the hypotenuse is 2. So 1, negative root 3, and 2. According to the CAST rule, CAST in quadrant 4, where this belongs, only cosine is positive, so sine would be negative, and opposite is root 3, hypotenuse is 2. So negative root 3 over 2 is my answer. Okay, so that's what I mean. When you want to find using a special triangles, when you want to find the trig ratios, this is what you do. So you draw the unit circle, you figure out where the angle belongs to, and then you draw your special triangle and then solve it. So let's say if this question comes in a test or in an assignment, you have to show the work, and you should be able to find the final solution. Okay, so special triangle, trig ratios, sine law, cosine law, these are the concepts that we talked about before. But what is new in grade 12? Like I said, the new thing here is we're going to be dealing with different unit, which is radians. So what is a radian? 1 pi radian equals to 180 degrees. You know how we convert different currencies? For example, $1 equals to roughly 1.35 or 38, whatever, Canadian dollar, right? So that means like $100 would equal to 135 or 138 Canadian dollar, right? 1 pi radian equals to 180 degrees, or basically 2 pi radian, which is one complete circle, would equal to 360 degrees, okay? And in short, radian, we show that by rad, R-A-D, or just 2 pi. If it's in a pi format, then you know it's a radian format, okay? So if you want to convert from degrees, let's go from degrees first. If you want to go from degrees into radian, you're going to multiply by pi divided by 180. And if you want to go from radians into degrees, you're going to multiply by 180 over pi, okay? So for example, if I'm told what is 3 pi over 2 radians equal to in degrees, just multiply by 180 over pi. So what happens, as you can see here, pi and pi will cancel out. So that technically is 3 over 2 times 180, which is 3 times 180, which is 540 divided by 2 is 270 degrees. Okay, just like that. All right. Any questions so far before I continue? All good? Let me see if I screenshot this. Up to here. The concepts of trig identities and trigonometry in general is easy if you understand what you're doing and if you understand the concepts well. So in order to do that, you have to practice more. So let me screenshot this angle. It's two special triangle, the example, and radian degrees. Okay. So now, what I would like you guys to do, let me stop share here. Already got the screenshots. Okay. What I would like you to do is to practice some of these questions. So for right there. Perfect. Sharing screen. So chapter 6, these are the review questions. We're going to talk about the graphs later on. So don't worry about period, amplitude, equation of axis. Don't worry about those stuff. Those stuff will come out later. But as you can see here, we have the two special triangles, 45, 45, 1, 1 root 2, 60, 30 degrees, 1 root 3, and 2. Can I ask you guys to question 2, and that's it, question 2 only from this page. And let me try the next questions on the other page. So question 2. So it says 0.3, -4 lies on the terminal arm of an angle in a standard position. Sketch the angle and determine the values of the primary and reciprocal ratios. Determine the measure of the principal angle to the nearest degree. So I'll give you 2 minutes, give it a try, and then we solve it together. Try to sketch it first to see where it's located and then solve it. In recording, does that every single time. Okay, perfect. So let's go with white. All right. So if I want to figure out the angle theta is going to be the angle that makes with the x-axis. So sine theta is going to be -4/5. So therefore cosecant theta would be the reciprocal. So that's -5/4. Cosine theta is going to be 3/5 adjacent over hypotenuse. So therefore secant theta would be 5/3. And tan theta would be -4/3, which is opposite over adjacent. So therefore cotangent theta would be -3/4. And then if you want to find the angle, so we have two angles. If you remember, we have the acute angle, the related acute angle, which is going to be the angle that it makes with the x-axis. So I'm going to put it in green. So let's call that beta here, the small angle there. So if you want to find beta, angle beta could be, we can use sine, cosine, or tangent, doesn't really matter. We can go sine inverse of -4/5. So beta would equal to, so let's do that here, sine inverse of 4/5. That gives me 53 degrees. So, right? So that is roughly 53 degrees to the nearest degree, it says, right? So 53 degrees, 53.1, so 53 degrees. So that is 53 degrees less than 360. So theta, which is going to be from 0 all the way down there. So theta would equal to 360 degrees minus 53 degrees. So 360 minus 53 is 307. 307 degrees, that would be the angle there, right? So these are the steps that we take to figure out the value. This is the concept in grade 11 that we built up, and we're continuing in grade 12 as well, okay? And like I said about a period, amplitude, equation of axis, graphing, we're going to come back to it later. So focus on this solving here. So radian, what is a radian? Radian is the size of an angle that is subtended at the center of the circle by an arc with a length equal to the radius of this circle. Both the arc length and the radius are measured in units of length, so such as centimeters, meters, feet, inch, whatever. The angle is a real number without any units. So basically, if you want to find the length of this red portion, that is the arc length, and the radius is the radius of the circle here, right? So now, 1 radian is defined when the arc length, the red line, or the red curve, better to say, equals to the length of the radius. If they equal to each other, then the angle would be 1 radian. And if you divide a whole circle based on radian, you're going to have 360 pieces or slices, okay? So that's why 2 pi radian is going to be 360 degrees. So the relation between degrees and radians would be 1 pi radian equals to 180 degrees. So 1 pi radian equals to 180 degrees. Okay, pi radian, 1 pi radian would be 180 degrees. So now if I want to convert degrees into radians, like we did before, we're going to multiply degrees by pi over 180. So for example, let's do this one together. This is pretty easy. So 20 degrees multiplied by pi divided by 180, that would equal to pi over So 0 and 0 cancels out over 9. So pi over 9 radians. This is for part A. Part B, 225 degrees multiplied by pi over 180. And that would equal to pi over, so 225 divided by 180. That is 5 pi over 4, right? So 5 pi over 4. If you simplify, I did divide these two numbers by each other. Got 200. I got 225 divided by 180, which is 5 over 4. And then there's a pi beside it. Simple as that. So when you want to convert from degrees into radians, multiplied by pi over 180. That's what I wanted to learn from here. And vice versa. If you want to go from radians into degrees, like this question here, you're just going to multiply it by 180 over pi. Let's give it a try together. These are simple questions, so we can just do it together here. So, okay. So for part A, 5 pi over 6 radian multiplied by 180 over pi. The pi and pi will cancel out. So 6 divided by 6 is 1. 180 would be 30. So that's 150 degrees. Okay. Part B, 1.75 radian multiplied by 180 over pi. To the nearest degree, I have to just plug in my calculator. 1.75 multiplied by 180, and make sure you put the pi in your calculator. Don't put 3.14. Don't put 3.14. To the nearest degree, that would be 100 degrees. Because that's 100.26, right? 100.3. So to the nearest degree would be 100 degrees. Okay, cool. So radians to degrees multiplied by 180 over pi. Alrighty. Okay. So let's move down to more complex problems. This is pretty easy. This is just introducing you to radians. In 6.2, we talked about the special triangles. So we talked about special triangles in grade 11. As we said, 45, 45, that would be 1, 1, root 2. 30, 60, 1, root 3, 2. But how about if I want to convert it into radians? Because moving forward, now we're going to talk about radians. This is a new unit. So 45 degrees. So the 45, 45 triangle would look like pi over 4 radian, pi over 4 radian, and that would be 1, 1, root 2. For 60 degrees, so 60 degrees, which equals to pi over 3. 30 degrees equals to pi over 6. So therefore, the triangle will look like this. Will look like, so this is 90 degrees here. 60 degrees is pi over 3. 30 degrees equals to pi over 6 radians. So this is 1, root 3, and 2. Okay. These are the two special triangles that we're going to be dealing with a lot. Okay. So moving forward, make sure you remember. You have to memorize them. This triangle will not be given to you in the exam. You have to memorize them. Okay. Okay, we did that already. So let's move down. We talked about the unit circle and how you find the angles already. So let's solve some questions here. Okay, so let's see actually, this is pretty easy. Let's go another one. Sorry, not this one. This is sine of pi and 3 pi over 2. Okay, yeah, this one. All right, how about if I want to solve something like this? The question says, okay, one thing, whenever you see the word exact value, that means you have to use special triangle, okay? In this question, I see the word exact value right about here, right? That's an indicator that I have to use a special triangle. And if you see that it's in pi format, that means you have to use radians. And make sure your calculator would be in radians mode too moving forward, guys. Okay? And for grade 12 students, grade 11 is still going to be degrees. So cosine of 5 pi over 4. Well, if I split 5 pi over 4, this is like pi plus pi over 4, isn't it? And then for part B, cosecant of 11 pi over 6. If I split it, isn't it like 12 pi over 6 minus pi over 6, or basically 2 pi minus pi over 6? Knowing cast rule, can you guys go ahead and solve it? Let me give you a minute to think about it before I solve it with you. Give you a minute to think about it yourself, and then we solve it together. Go ahead and give it a try. All right. So, for part A, I'm asked to figure out cosine of 5 pi over 4. I know it's pi plus pi over 4. That means if this is my unit circle, so pi radians means like 180 degrees, right? So 180 degrees or pi radian would be located at, so I know that 0 is right about here. So pi radians would be here. I'm going pi over 4 more or 45 degrees more. So this is where I'm going to land. I go perpendicular always to the x-axis, always x-axis. If I zoom into this triangle here, so I'm in quadrant 3, according to the CAST rule, CAST, this is the tangent quadrant, so cosine must be negative. So if I zoom in, this is 45, 45 triangle, right? Or pi over 4 triangle. So this is pi over 4, pi over 4. So -1, -1 and √2. So I'm dealing with cosine. Cosine is adjacent, which is -1 over hypotenuse, which is √2. -1 over √2 or -√2 over 2. You can leave it as that, or you can rationalize it and write it as -√2 over 2. Either or is the same thing. Cool. For part
Wait,
B,
sir.
yep.
Why would you, which one would you do? -1 over √2 or √2, -√2 over 2? Which one is
Same,
like,
same thing, but better, like more rationalized would be -√2 over 2. But if you write it as -1 over 2, that's not wrong. That's the same thing, right?
okay.
Yep. Navid?
Okay, sir, so then how did you get the 5 pi over 4 to be pi plus pi over 4?
So good question. So what I recommend at the beginning to do is convert it into degrees first. So 5 pi over 4. So you see it better. In order to convert it into degrees, you have to multiply by 180 divided by pi. So that means pi and pi will cancel out. So 5 over 4 times 180. 5 times 180 divided by 4. That gives me 225 as expected, 225 degrees. So 225 degrees is between 180 and 270, right? So that's like 180 plus something. That something must be 45. Remember earlier we talked about the special angles. 225 was one of them. So 180 is what? Pi radians. What is 45? Pi over 4. And you're doing addition, so plus. That's how I did it. How do I know that quickly? I practice a lot. That's the only simple reason.
Wait, how
Uh,
did you get it to equal 180 plus 45? It was
That
you just took the 225 and then you just
I asked myself, which quadrant does that belong to? Right? 225 in quadrant, it belongs to quadrant 3, which means it's between 180 and 270.
oh, okay.
You could say actually, you could say 180 plus 45, or you could say it's 270 minus 45, which is 3 pi over 2 minus what is that? 4 pi over 4, sorry. Right? You could do that way too.
Got it.
So that would look at the location would be the same thing again still. Okay, so what I want to figure out here, the goal is to figure out the pi over 4, actually, honestly. This pi over 4 is the key. I want to see, is it pi over 4, or is it the pi over 6, pi over 3 special triangle? Because the question says exact value. That is an indicator that I have to use special triangle. Just want to know which special triangle should I use. The moment you figure out the pi over 4, then it's going to be pi over 4 triangle. Otherwise, the question will not tell you special triangle. Okay. All right. Just gonna give myself some space here. So yeah, at the beginning, convert it into degrees so you can see it easier. Like 11 pi over 6 is a little bit vague. Like where is that? If I want to just do the same process to that, 11 pi over 6, if we multiply by 180 over pi, the pi's will cancel out immediately, and then that would be 11 times 180 divided by 6, which is 330 degrees. So 330 degrees, isn't that 360 minus 30, right? So it's like, why am I saying, because I know 330 is in quadrant 4, which is like 270, between 270 and 360 is closer to 360. So, and anyways, I'm going to use 360 instead of 270. Same thing to part A as well, because I want to go perpendicular to the x-axis. Previous one, like in part A, we have to go, how far is it from x-axis, which is 180. This one, the x-axis would be 360 in quadrant 4, right? So 360 is 2 pi and minus 30, which is pi over 6. That's how I got it there. Okay. And okay, what else? And I know that cosecant is 1 over sine. So I'm dealing with sine here. So this is my little triangle here. If I zoom into that. So this is the angle 30 degrees or pi over 6. Let's write it as pi over 6. Moving forward, we're going to write it. So this is pi over 6. If that's pi over 6, the other one should be pi over 3. So this is going to be root 3. This is going to be -1 because it's going downwards, and this is 2, right? Pi over 3, 60 degrees in front of it is going to be the bigger side, which is root 3, and then pi over 6 is 30 degrees in front of it would be a smaller side, which is 1. In this case, it's going down below the x-axis, so it's -1. Hypotenuse, regardless of the quadrant, is always going to remain positive. Okay, so one more time. Cosecant is 1 over sine, right? So, and according to the CAST rule, CAST, only cosine is positive. So cosecant is 1 over sine. So cosecant of 11 pi over 6 would be 1 over sine of 11 pi over 6. And sine is negative in this quadrant, opposite, which is -1 over hypotenuse, which is 2. So 1 over -1 over 2, which is going to be -2. I know you guys can plug the whole thing, you're calculating the final answer, but that would not give you any mark because the question says use exact value. But using your calculator would be a good, like a double check that you did it correct. That's another thing that you can do, right? Because you can literally punch the whole thing and just plug in cosecant 11 pi over 6. In some calculators, you cannot put a cosecant, so you have to do like 1 divided by sine of 11 pi over 6, right? Or 330 degrees if it's in degrees mode. Okay. So let's practice more of these so you can see how it's done. These are like basic questions. So convert from degrees into radians. Make sure you're dealing with special triangles too. Okay. All right. Now, if you want to solve an angle, how does that work? So like this question here, example 4. So it says tan theta is -7 over 24. Tan theta is -7 over 24. So that is opposite is -7. Adjacent is 24. And theta is an angle between 0 and 2 pi. So that's like 1 complete cycle. Solve for angle theta. Okay. According to the CAST rule, tan is positive in quadrant 1 and 3. So that means theta should be in quadrant 2 or quadrant 4 since it's negative here. One more time. Tan theta is always positive in quadrant 1 and 3 since it's negative here. So that should be quadrant 2 and quadrant 4. So if I want to draw my unit circle, something like that. So my solution should be somewhere in quadrant 2 or quadrant 3. I go perpendicular to the x-axis. So I'm going to have this red triangle here, or in quadrant 4, this blue triangle here, right? Okay. They have a small angle, which I call it beta here with the x-axis. Always you go with the x-axis, beta. But we're looking for theta, which is going to be from 0, from the origin. Okay. So how do we solve that? In order to solve for beta, you can use tan inverse. When you're doing tan inverse, listen carefully. You're going to put the absolute value of the given number. So -7 over 24, you just put +7 over 24 in calculator. Why? Because I want to find beta, which is the positive value there. So tan inverse of 7 over 24. Which is to the nearest 100, that would be 16.26 as the question asked. Nearest 100 means 2 decimal places, 16.26. Yeah. Okay. So that is beta. And if that is beta, theta would be, so for theta 1, let's call that because we have 2 solutions, right? In quadrant 2, I'm going to write it in red actually so you can see the difference. In red. Okay. Theta 1 in quadrant 1, that would be 180 degrees minus 16.26. 180 degrees, you start from 0, go all the way to 180. Then you go 16.26 backwards. So you go 180 degrees counterclockwise and then 16.26 clockwise. So that's going to be your first solution, which is going to be 180 minus 16.26, That is 163.74 degrees. If you want to convert it into radians, what do? Multiply by pi divided by 180. So times it by pi over 180. That gives me to the nearest hundredths. That would be 2.86 radian. That is theta 1. Theta 2, similar manner. For theta 2, which is in quadrant 4, that would be 360 degrees minus 16.26, right? That is like going one complete circle all the way to here. That is counterclockwise, so positive 360, and then 16.26 clockwise, sorry. So 360 counterclockwise, 16.26 clockwise. That's why it's negative. So that would be 360 minus 16.26. So that is 343.74 degrees. Same manner, multiply by pi over 180 to convert it into radians. So times pi over 180. That is 5.999, which is like 6.00 if you round it to the nearest 100, right? Yep, 6.00 radian. And now I'm done. So I have two solutions, one in quadrant 2, quadrant 4, since tangent is negative. And in order to figure out the related acute angle beta, which is a small angle that it makes with the x-axis, always x-axis, doesn't matter the value, doesn't matter if it's smaller or bigger, always beta is going to be the angle that it makes with the x-axis. Okay, so in order to figure that out, you're gonna go tan inverse of the absolute value of given number. So if it's negative 7 over 24, positive 7 over 24. And then based on this question in quadrant 2, that would be 180 minus beta, and quadrant 4 would be 360 minus beta, and that's it. Okay. I don't want you guys to memorize anything, but if that helps you to see it better, I can tell you this. Don't memorize it though. Promise me that you're not gonna just memorize it. Try to understand it. But if you memorize it, that would work. But I don't want it to memorize things. Oops, I don't like it. Okay. So if it's in quadrant 1, beta and theta are equal to each other. If it's in quadrant 2, theta would be 180. 180 minus beta. If it's in quadrant 3, theta would be 180 plus beta. If it's in quadrant 4, theta would be 360 minus beta. Okay, that's the rule there. And then that's in degrees, and then you convert it into radians. Cool. And that kind of makes sense if you think about it, because in quadrant 1, beta and theta are the same thing. Beta and theta are the same thing. In quadrant 2, right, this is beta, but theta, theta would be like from 0 all the way to here. That is theta, right? So in quadrant 3, this is beta again, but you're gonna find theta. Theta means again from 0 all the way to here. So that's why it's 180 plus beta. And the last one is quadrant 4, which is gonna be 360 minus beta, because again, you go one complete cycle, you go all the way around counterclockwise, and then you go beta degrees clockwise, right? So if that helps you to solve it better, go with that. Okay. All right. Let's move on. So we already talked about the special triangles. Like I said, pi over 4, pi over 4, 1, 1 root 2, pi over 3, pi over 6, 1 root 3 and 2. And we can, based on that, you can figure out these angles and sinusoidal equations. And a cast rule, we talked about it. Trig ratios, we talked about it. Sine, cosine, secant, cosecant, tangent, and cotangent. All 6 trig ratios. Okay. Can you guys solve question 16? Move that up. Question 16. So 16 is a very nice one. So a little bit challenging though, but give it a try. So it says determine the length of AB. Find the sine, cosine, and tangent ratios of angle D, given that AC and CD are equal to each other, which equal to 8 centimeters. All right, and you know that angle B is pi over 6 radians, so it's in radians mode. So, and C is 90 degrees here. All right, I give you 2 minutes, solve it, and then yep. Word problem application thinking questions, guys. So, how do we solve this? Let's analyze it again. So if B is pi over 6 in the triangle ABC, A is gonna be pi over 3. Okay, and I know that angle angle C is 90 degrees. So I want to figure out side AB. So in triangle ABC, so I'm gonna go and do sine of B, which is pi over 6, is going to be opposite, which is 8 over hypotenuse, which is side AB, right? So if you rearrange it, AB would be 8 divided by, they switch the sides, so sine of pi over 6. So side AB would equal to 8 divided by sine of pi over 6. Make sure your calculator is in degrees, in radians mode. So 8 divided by, otherwise you're gonna get weird answers. Pi over 6 radians, and I got 16. You don't need a calculator for that, honestly, because you know this is a special triangle. Sine of pi over 6 is sine of 30 degrees, which is 1/2. So AB is 16. I'm just plugging my calculator just in case. Okay, just double check my work. So AB is 16 centimeters. So this is AB. All right, I know that AC is 8, CD is 8. So what does that suggest? That suggests that ACD is an isosceles triangle. That means, so knowing that angle C is 90 degrees here, I'm going to change my color to red. Actually, let's write it with red. So this is going to be pi over 4, 45 degrees, or pi over 4 radian. This is pi over 4. And this side is 8, this side is 8, this side is going to be 8 root 2, right? 1 root 2, 5 root 2, 8 root 2, right? M root 2, 10 root 2, right? General, you can put whatever, just root 2 beside it. That would be your hypotenuse. Okay, but the question asked me, find the sine, cosine, and tangent ratios of angle D, given that AC and CD are 8. So then I'm gonna go refer to the triangle ACD. So in the triangle ACD, sine of D, angle D, which is sine of pi over 4, is going to be opposite, which is 8 over hypotenuse 8 root 2, which is going to be 1 over root 2, or if you want to rationalize it, that would be root 2 over 2. Cosine of angle D, which is going to be cosine of pi over 4. That would be, again, adjacent, which is 8 over 8 root 2, which is just going to be root 2 over 2, same thing. And tangent of angle D, that is going to be tan of pi over 4, which is obviously going to be 1, right? That would be 8 over 8, which is 1. Okay. So the moment you figure out angle D is pi over 4, your job is pretty much done, right? It becomes a pretty easier question. Okay, question 15 is pretty easy, but let's give it a try. Let's just give it a try, just to practice more, but we're gonna do it together since it's easier, so we can have time to go over the rest of it. Okay, so question 15. So 2 sine square theta minus 1 equals to sine square theta minus cos square theta when theta is 11 pi over 6. So it says show that this is equal, left side equals to the right side. So that means 2 times sine of 11 pi over 6, okay, square, minus 1, that's your left side. So what can I put instead of sine of 11 pi over 6 if I want to use this special triangle? That is, isn't that sine of 2 pi minus pi over 6, right? 2 pi is like 12 pi over 6 minus pi over 6, and then the whole thing square minus 1. That's my left side, isn't it? So 2 pi minus pi over 6, so that would be sine of, that would be like negative sine of pi over 6. Why is it negative sine of pi over 6? Because in quadrant 4, that would be quadrant 4. In quadrant 4, that sign is going to be negative. So that would be negative sine of pi over 6. According to the special triangle, sine of pi over 6 is like sine of 30 degrees. That would be 1/2. So negative 1/2 square minus 1. And what would that would equal to? That would be 2 times 1/4 minus 1, which is negative 1/2, right? 2 times 1/4 is 2/4, which is 1/2, minus 1 would be negative 1/2. Let's try the right side. Right side would be sine square of theta. So theta is 11 pi over 6. So that is sine of 11 pi over 6 square minus cosine of 11 pi over 6 square, right? So with the same manner, sine of 11 pi over 6 is sine of 2 pi minus pi over 6, which is going to be negative sine of pi over 6 square minus cosine of 11 pi over 6 is cosine of pi over 6. Same thing, because in quadrant 4, cosine is positive anyways. So that would be negative 1/2 square minus 1 square, which is going to be 1/4. Wait a second. Am I doing a mistake? Cosine of pi. Oh, cosine of pi over 6. Sorry. Why did I put a 1? Cosine of pi over 6 is what? Cosine of pi over 6 is cosine of 30 degrees, which is √3/2. Right? Just double check. Cosine of, yeah, am I doing it correct? I'm doing it quickly. Pi over 6, which is √3/2 squared. Okay, yeah, that would be 1/4 minus 3/4, which is going to be negative 2/4, which is negative 1/2. So we just showed that left side, therefore left side equals to the right side. Just give me a second, Navid. And they equal to each other. Perfect. Okay, Navid.
Do we need to be doing the exact steps that you're doing? Like the converting 11 pi over 6 to pi over 6?
What else would you do?
I would just keep it as 11 pi over 6 and then just
So if you
effectively.
get, okay, the reason the question says show that this equals to that, well, that would be very, like, I know what you're saying, like saying, okay, sine of 11 pi over 6, just plug in your calculator, right? But you want to use a spatial triangle. For this question, if a question like this comes in the exam or test and you do what you said, you get a full mark. But honestly, my question, I will tell you, using spatial triangles show that blah 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 equals to blah blah blah, right? So that using a spatial triangles, that means I wanted to see the pi over 6 somewhere, or pi over 3, or pi over 4, right? These are the spatial angles that we're dealing with. Pi over 4, which is 45 degrees, pi over 3, which is 60 degrees, pi over 6, which is 30 degrees. So I want to see those numbers. So in order to do that, I have to convert it.
Wait, so then how'd you know that 11 pi over 6 is 2 pi minus pi over 6? That's 360 minus, oh, 360 minus 30.
Yeah, 360 minus 30. Or again, I know 11 pi over 6 belongs to quadrant 4. In quadrant 4, that would be 2 pi minus beta. And that beta would be like what would be added to 11 pi over 6 to become a full circle, or 2 pi over 6. So that would be 2 pi minus pi over 6, right? That's how I got it. And then in quadrant 4, sine is negative, so that's why I put a negative sine pi over 6. In quadrant 4, cosine is positive according to the cast rule. So cosine of 11 pi over 6 would be the same thing as cosine of pi over 6. So they're the same thing.
So then how come on the right side, your 11 pi over 6 just turned into pi over 6 and you didn't do the 2 pi minus?
Oh, I just skip that part because it's the same thing, right? You could write it again. 11 pi, so same thing. Sine of 11 pi over 6 is sine of 2 pi minus pi over 6, which is going to be negative sine of pi over 6, right? Because I already showed that here. Sine of 11 pi
Oh,
over
you just skipped that step.
Yeah, because I showed that already.
Oh,
And then
because you
the
don't
same,
need the 360, like the 360 minus that is just redundant.
Yeah, that's redundant. So I'm just skipping that part because I already showed that here. Sine of 11 pi over 6 would be sine of 2 pi minus pi over 6, which is negative sine pi over 6. So instead of sine of 11 pi over 6, you can put negative sine of pi over 6. So instead of sine of 11 pi over 6, I put negative sine of 11 pi over 6. Cosine of 11 pi over 6, again, according to Cast rule, that would be cosine of 2 pi minus pi over 6, which is going to be quadrant 4, which cosine is positive. So same thing. Okay.
Okay.
Again, when a question says using like show something equals to something, you have to use like special triangle. Wait, why is it not? Okay. Let's zoom out a bit. All right. I think the rest are good. Yeah, that's good for now. We're gonna come back to it later if you have time. Okay. The graph of primary trig ratios, don't worry about the graphs today. So up to 6.3 here, I'm gonna skip the graph. We're gonna talk about it more tomorrow. Transformations as well later. Although this is nothing new, we did that in grade 11. Okay, up to mid-chapter. So now, what I would like you guys to do in the afternoon, I would like you to go over mid-chapter review questions here. As you can see, 6.1, 6.2, 6.3. Don't worry too much about it. So it's just 6.1, 6.2 basically, and then try those questions first. Also, I'm gonna post something that you can practice for 6.1, 6.2. Exploring graphs of the reciprocal trig functions is something gonna be new for everybody. That would be secant, cosecant, and cotangent. I'm gonna talk about it quickly now. And then we're gonna be transformations of trig and then application questions. So let me share my screen on whiteboard. Let me just go down here. Yeah, we covered everything. And then the rate of change, which we're going to skip that. So 6.7, we're going to skip it. So that's not going to be included. Don't worry about 6.7. And that's pretty much it, the whole chapter. But there was a good question I was looking for. Was it a chapter test? I think chapter 6 test question. We can do that. Can we do question 5 here quickly, and then I'll go over graphs and then we call it a day. Question 5 says arrange the following angles in order from the smallest to the largest. So 5 pi over 8, 113 degrees, 2 pi over 3, radians 110 degrees, 3 pi over 5. Arrange them from smallest to the largest. Can you give it a try? So in order to do that, you can convert everything to degrees or everything to radians and then see which one is bigger. I would convert everything to degrees so I can see it easier. So convert the radian ones to degrees and then go from there. Give you a minute. Resume. Okay. So like I said, I'm going to convert the radian ones into degrees. How do you do that? Multiply by 180 divided by pi. Same thing with this one, 2 pi over 3 times 180 over pi. 3 pi over 5 times 180 over pi. And then we're going to have it in degrees. Pi's will cancel out. So that is what? 5 times 180 divided by 8. That is 112.5. 2 times 180 divided by 3, that is 120 degrees, right? And then 3 times 180 divided by 5, that is 108 degrees. Okay, let's put in from smallest to the largest. That is the easiest task in the world, right? 180 degrees or 3 pi over 5 radians. Next one is going to be 110 degrees. Next one is going to be 112.5, which is 112.5 degrees, which is same as 5 pi over 8 radians. Then we have 110 13 degrees. Then we have 120 degrees, which is same as 2 pi over 3 radians, right? So from smallest to the largest. So convert into all of them into degrees or all of them to radians and then rearrange them, right? I like to convert everything in degrees. That's easier numbers to see. 108, 110, 112.5, 113, and 120. Yep. Okay. That's it. All right. So I think that's enough for that. For graphs, very brief, I would like to talk about the graphs briefly with you guys, and then we call it a day. So graphs of sinusoidal functions. So the sine function y equals to sine theta. If you remember from grade 11, this is the x-axis, this is the y-axis. Sine function, they are called periodic functions because they repeat their cycle. So if this is one cycle of sine function, then it's going to repeat again here, and it repeats here, right? And it keeps going over and over again forever, right? Let me draw that part again. It goes to the minimum and then maximum, and then goes down again, and it goes forever to the right, forever to the left. Okay, but if you're focused on the one complete cycle, maximum is 1, minimum is 1. One complete cycle occurs in 360 degrees, which is 2 pi radians. The other zeros will look at as 0 at 180 degrees, which is pi radians. The maximum occurring at 90 degrees, which is pi over 2 radians. Minimum is occurring at 270 degrees, which is 3 pi over 2 radians. Okay, maximum 1, minimum -1. Domain for sinusoidal function would be x belongs to any real number, except the parts like a word problem where x represents time, cannot be negative, obviously, right? That would be a different story. Range is going to be y belongs to any real number bounded between -1 and +1, right? -1 and +1. Okay, so that is sine. And the graph of cosine function would be very similar to this. So y equals to cosine theta. Instead of starting from 0, cosine starts from the maximum value 1. It goes all the way down to minimum value, which is -1, and it goes bounce back up to +1 again. It kind of looked like a U shape, right? And same thing as sine. It's a periodic function. That means it repeats on the right side and left side. One complete cycle occurs at 360 degrees or 2 pi radians. Minimum value would be in the middle, which is 180 degrees or pi radians. The x-intercepts will be located at 90 degrees or pi over 2 radians and 270 degrees or 3 pi over 2 radians. Okay, so maximum is 1, minimum is -1. Okay. And that's pretty much the graph of sine and cosine. We do have transformations for the sinusoidal functions. Again, we're going to talk about it tomorrow morning, but I'm going to talk about the graphs very briefly. I mean, the rules very briefly, and then we're going to talk about the graphs tomorrow. So if I'm given y equals to a, sine or cosine, so I'm going to put sine here, k bracket x minus d plus c. Like any other function, if a is negative reflection over the x-axis, k is negative reflection over the y-axis, a is a vertical stretch compression, k is a horizontal stretch compression, d is horizontal shift to the right and left, and c is vertical shift up or down, right? Now, how does that affect the 6 important information about a graph? Number 1, amplitude. Amplitude is kind of like the height of the graph, which is going to be absolute value of a. Number 2, period, is going to be 360 degrees over absolute value of k. Number 3, if you want to find the maximum point, that would be c plus absolute value of a. If you want to find minimum, that would be c minus absolute value of a. And if you want to find axis of symmetry, or axis in short, it's going to be just c. And number 6, which is going to called phase shift, that will be d. Using these 6 information, you can graph any sinusoidal function, sine or cosine function, right? Now, in some questions, they give us backwards question. They give us a graph and they ask you to write the equation. So that means you need to find A, K, C, and D, right? So in order to do so, you need to find the equation. So we write the equation for absolute value of A, that would be maximum minus minimum divided by 2. For C, that would be maximum plus minimum divided by 2. For K, or absolute value of K, better to say, is 360 degrees over period. And for D, that is a phase shift. So you have to look at the graph and see how much the graph has been shifted to the right or left. And that would be your D value. Or sometimes if it's not exact value, you need to find a good point and plug it in as X and Y and solve for D. Now, saying this, for advanced function, like I said, we're dealing with radians. So wherever you see 360, you can put 2 pi radians, right? Same as here, back up there. If it's 360 degrees, that would be 2 pi radians. So if you're dealing with radians, go with radians. If it's degrees. So be careful with the unit, guys. So these are all the rules you need to know for graphing a sine or cosine function. In advanced function, we're going to be dealing with tangent, secant, cosecant, and cotangent as well. In grade 11, we talked about tangent a little bit. We just introduced the graph, but more details are going to be in grade 12, okay? Honestly, if you understand sine and cosine graphs well and you're able to do the transformations properly, then you should be fine with the graph of the rest of trig ratios, to be honest with you, okay? Any question? All good? All right. So if there's no question, I think we can end it here. I'm gonna post the videos and the notes for today as well on Edsby. I would like you to try, like I said, the mid-chapter review. For grade 11, that would be chapter 5. For grade 12, that would be mid-chapter review for chapter 6. Okay, only pertaining to 6.1 and 6.2. And that would be for today. Tomorrow, we're gonna go over the more transformation questions so you can, solve the rest of the questions in chapter 6. And then chapter 7 is gonna be very interesting. My favorite is gonna be chapter 7, to be honest with you, which is trig identities, proof-based problems, solving trig equations, and inequalities as well. Okay, so tomorrow, however, for grade, again, reminder for tomorrow is gonna be unit 2 test for grade 12 MHF. So that would be chapter 5 in the textbook. And for MCR, for functions 11, for Justin and Haron would be chapter 5 test. Okay. And chapter 6 assignment is gonna be in the afternoon for MHF. Okay. If there's no more question, I'm gonna stop it here. Have a great day, guys, and I'll see you later. Take care.
Sir,
Thank you.
are you gonna